So now I have summarized the solutions of nonlinear equations. Now let's move to the point of nonlinear matrix equations. In chapter 4, we have explored the Riccati equation. The equation behaves like this. So this is the Riccati equation. And I introduced a function called ARE, algebraic Riccati equation over ARE function, to find the equation 2x. However, with the ARE function, we can only find one solution to such an equation. And in fact, it seems that there should be more solutions because it is a quadratic solution. There might be more solutions. However, with the use of ARE, we can only find one solution. So now our question is whether we can find more solutions using the method we discussed here. And also, if we generalize the original equation to something like this, I don't think there are any published thing about this kind of equation. If you change A here to D, or you change A here and then put this A here to D, and this is what we call it generalized Riccati equation. And also you modify the Riccati equation here just by take the transpose of this one, just to make variation to the original Riccati equation. And the ARE function will no longer be usable. So in this case, we have to explore ways to solve this kind of equations. And in the book and in the slides, I have listed several algorithms, but I have listed the equation, matrix equation solver, but in the new versions, we do not have to use this method. So I will introduce you with either way to solve the problem. In the first lecture, in the previous lecture, I said that the standard form of a nonlinear equation is something like this, where x, f, and y are vectors. Actually, they do not have to be vectors. They can be matrices as well. As long as the size of x and f are the same, they can be matrices instead of vectors. So, for solving this kind of matrix equations, we can easily describe it like this. However, before this one, we have to specify A, B, C, D matrices first. And then we can use this command to describe the matrix equation. And then we can use fsolve command to solve this equation directly. Now the previous method in the book or in the slide are quite complicated. I'm not going to address them like that. So now let's consider a new way of solving such equations. This is the A matrix, this is the B matrix, and this is the C matrix. How can we find the solution to this Riccati equation? And this equation is from chapter 4, where we use ARE function to solve it. However, we found only one solution to this equation. So can we solve it again, find more solutions? To solve this equation, what we need to do first is to enter A, B, C matrices, and then describe the Riccati equation, and then use fsolve to solve it. So we can use commands like this. To specify A, B, C matrices. And then for f equals to at x, go back to the standard form. A transpose times x plus x times A minus x times b times x plus c. So this is the form to describe the Riccati equation. And then we can find the solution to it. Right? So capital F, and initial search point I can use a random 3 by 3 matrix. And then we can solve it. And this is the final result we obtain. We can choose the Chen format. And this should be the solution to it. First, let's see x1 equals to ARE, A, B, and C. See, they are different. And let's check the small x. And small x. We see that it is also a solution to the original problem. And we can increase the accuracy. So OPT here. Another different one. And which is quite accurate. And if we change the initial search point, we may find the different ones. We have already found 3 different ones here. And the most difficult question is, how many solutions can we find? No theoretical result to this one. So I will explain this topic later on. We can find different ones with the repeated use